Welcome to Miss Lovedoll's video on deforming Earth's crust. This video is all about stress and folds. The objectives are to describe two types of stress that deform rocks and to describe the three major types of folds. We can see examples of the forces inside the Earth all the time. This is an example of building damage created by the Loma Prieta earthquake in 1989, and that was along the San Andreas Fault. And then this is an example of a train track that was deformed by the Canterbury earthquake in New Zealand in 2010. And then this is a huge fissure created in the road by the Honshu earthquake in Japan in 2011. And that's the same earthquake that created that huge tsunami. But earthquakes are only a sign of the stresses inside the Earth. The stresses inside the Earth that change and bend rock are all called deformation. Rock layers bend when stress is placed on them. Look at this bend in this rock right here. You can see this is a geology rock hammer placed here for scale. If rocks are placed under enough stress, they actually snap and break, creating really jagged mountains like these in the Canadian Rockies. Stress is measured as the amount of force per unit area on a material, but geologists have a hard time measuring stress directly. And the rocks in the Earth's crust experience different types of stresses, so geologists tend to look for signs of these stresses. Compression stress is created when two plates collide. This occurs at convergent boundaries. Compression stress creates really, really large mountain ranges. This is Mount Everest, where the Indian plate and the Eurasian plate are colliding. Compression stress is basically when rocks are being squeezed together. Tension stress is the other type of stress, and it's created when rocks are stretched. And you can see in this picture here that it looks like this block just fell down. And notice the rocks aren't folded, they're just offset. Tension stress can occur along mid-ocean ridges, like the mid-ocean ridge that runs down the center of the Atlantic Ocean, and then also in rift valleys. Here's the Rift Valley in Africa, and we also have a rift valley over here in the Baja of California. Nicholas Steno was one of the first scientists to really look into what was going on to change the shape of rocks. He observed that there were layered rocks in the Alps and high in the mountains, and that they were tilted and folded. He also observed in those same rocks that there were fossils that suggested that they were probably marine in origin, meaning that the rock layers were created at the bottom of the ocean. Based on these observations, he proposed the principle of horizontality. And what that says is that rock layers are originally laid down horizontally, and any tilting or folding of these rock layers occurs after they were laid down. And if you see tilting and folding, then you know that the rocks have been moved from their original position. In this picture, you can see some folded rocks right here. And then on top of them, you can see that deposition continued after this folding, and the deposition occurred in a horizontal manner. So what this means is we could conclude that these folds occurred after the original layers were deposited, and then these deposits were laid down after the folding occurred. There are three types of folds: anticlines, synclines, and monoclines. An anticline is an upward arching fold. So this is an example of an anticline fold right here. And I remember that because it looks like the letter A, and anticline starts with A. I always have to have tricks to remember things. A syncline is a downward valley-like fold. So this is a syncline in the same picture, in the same mountain range. And I remember syncline because you could draw the letter Y right there. There's part of the Y. So, and the Y is in syncline, so that helps me remember that. And then the last type of fold is a monocline, where both ends of the fold are horizontal. So you can see here are the horizontal rock layers, and then here's the fold, and then if the picture continued, you would see horizontal rock layers over here. A good way to represent that or think about that would be to think of a stack of paper. It's all horizontal when it's first laid down. And then if you put a stress on that stack of paper, and that's represented by the book, then you still have some horizontal layers at the beginning, and then the fold, and then horizontal layers going across again. So take a look at this fold. What kind of fold do you think that is? If you guessed syncline, then you are correct. Because here we go. This could be the letter Y. And it's a downward valley-shaped fold. Take a look at this one. What kind of fold do you think that these geology students are demonstrating? If you guessed anticline, then you would be right. So take a look at this rock layer. It's a really good one to look at. And if you trace it, it looks like the beginning of the letter A. So it's an upward-facing fold, so it's an anticline. To summarize, this video has told you about the two types of stress that deform rocks, and it's described the three major types of folds. You should know that rocks are deformed by stress, and that different types of stress cause different types of folds. There's a little bit of vocabulary, so make sure you write these words down. Deformation, compression, and tension, and then also folds, and the three types of folds: anticline, syncline, and monocline. Don't forget your 3 R's. Review your notes, reflect, choose the best reflection that fits your notes, and then respond to this question. Would you expect to see a folded mountain range at the mid-oceanic ridge? And explain your answer. And now you know about stress and folds in geology. Thanks for watching.